So today we will solve these questions based on what we have learned so far. Okay, and these questions are from Sikkim PSC last year question paper, assistant engineer, and UPSC and other PSC examinations. So total we will solve 16 questions, and these are the questions pattern which came earlier in the civil services examinations. Okay, question number 1. If a wire of resistance R is stretched to double of its length, then new resistance will be this question. Okay, so first of all, what is the formula of resistance? Resistance is equal to rho L upon A, where rho is the resistivity, L is the length, and A is the area. What it is saying, if a wire of resistance R, let's say this is a wire of resistance, its resistance is R. Now it is stretched to double. Now it is stretched to double means now this wire is stretched to double like this. So its new resistance will be, let's say its new resistance is R dash, and this wire is stretched and new wire is look like this. Then what will be the resistance? So you can see the area and length, area into length is equal to volume. Volume is constant in both the cases. In both the cases, volume of the wire is constant. Volume of the wire is constant. Let's say here in the previous case, when wire was not stretched, the area of the cross-sectional area of the wire is A and its length is L, and it is equal to volume. Now in this case, the new area and new length, but volume is constant, means this AL should be equal to A dash into L dash. Now what is the condition given? The stretched wire is double of its length, means L dash is equal to 2 times of L. Now you can find the value of A dash. A dash will be V divided by L dash, and V is nothing but A into L divided by L dash. Okay, now this will be A into L upon this L dash. This L dash is equal to new length, and new length is equal to 2 times of old length, means this is L cancel, and the new area of the wire is equal to A by 2, means the length of this stretched wire is 2L and its cross sectional area is A by 2. So the new resistance is R dash is equal to rho L dash upon A dash, and we can say it is rho L dash, means L dash is equal to 2L. L dash is equal to 2 times of L, and A dash is equal to A by 2. So you can write A by 2 means 2 will be here. So it will be R dash is equal to 2 into 2, 4 times of rho L upon A, and this rho L upon A was original resistance. This rho L upon A was original resistance. So I can say this is nothing but 4 times of previous R. So the new resistance will be equal to 4 times of old resistance. So the answer will be C. Is it clear to everyone? If it is clear, just drop a message in the chat box. Otherwise, I will repeat this once again, because here we are building our concept. Okay, just drop a message. If it is clear, then we can proceed. Okay, yes, is it clear? Please repeat. Okay, that's why I was asking. So let me repeat it once again. So your case, just see here what was the case. Let's say this is a material. Okay, this is a material, and its cross sectional area, this is the cross sectional area. This cross sectional area is A and its length is L. So what will be the volume of this material? Its volume will be area into length, no issue. And this resistance was offering the resistance R. And what is the physical definition of resistance R? R is equal to rho L upon A. This rho is equal to resistivity. I have discussed in the first class. This rho is equal to resistivity, L is length, okay, and A is cross sectional area, no issue. Now this is case 1. Now what you are doing here? Case 2. Now you are stretching this wire. Stretching in this manner, thus its length gets increased by 2 times. So the new length of the wire will be this. Now the new look of the wire will be like this. This is the new length. This is the new length. New length is L. It is equal to 2 times of old length. Okay. And if you are increasing the length of any material and its volume is constant. So L and A, the cross sectional area A will also change. So the new cross sectional area will be A dash. But what is given? The volume of the wire is equal to A dash. L dash is equal to old A into L. This is the condition. The volume should be constant. So if you are increasing L to L dash, definitely your area will be changed from A to A dash. This is the main concept of this question. Now what is the definition? Earlier in case 1 the resistance was R. Now let us assume the resistance is R dash. R dash is equal to nothing but rho into L dash upon A dash. Now you can ask, sir, what about rho? So rho is independent from the length and area of the wire. It depends on the material, type of material. The rho depends on material type, and we are not changing the material. We are increasing and decreasing its volume. So we can say rho is independent from the physical dimension of the material. It depends on the type of material. Okay. Now in this case, it is asked how this R is related to old R. What is the relation between new R when your wire is stretched and old R? So this relation can be found out by here. Now you can put R dash is equal to new R is equal to rho is constant. L dash, in place of L dash you can write, it is given L dash is equal to 2 times of L. You can write 2L. In case of A dash, you can use this relation for finding A dash. So just write A dash here, and from this equation write A dash is equal to A into L upon L dash, and here you can put A into L upon, and in place of this L dash you can write 2L, and you can write 2L. So L cancels, so it will be A by 2. So what is the relation between A dash and A? It is old area divided by 2. Means if you are increasing the length by 2 times, then its area will get reduced by 2 times to maintain its volume constant. Now you can put the value of this A dash, in this equation. So it will be R dash is equal to rho into 2 times of L divided by A dash. A dash is what? A by 2. A by 2 means what? 2 will come in the numerator. Now you can write in this way, rho L upon A into 2 into 2, 4. Now this rho L upon A is what? This rho L upon A was the old resistance. This is rho L upon A. Okay, so you can write this R dash is equal to, this is what? This is going to be R into 4. So final answer is equal to, the new resistance of the wire will be 4 times of old resistance. So its answer will be 4 times of old resistance. Okay, the C is there. Now let us see question number 2. A wire of resistivity rho is stretched to double of its length. What will be the new resistivity? Now I have just discussed the impact of resistivity on the length. What is the impact? The resistivity is independent. It is independent from the physical dimension. Getting? It is independent. That's why the rho will be same. So what was asked? It was asking a wire of resistivity rho is stretched to double of its length. What will be the new resistivity? The new resistivity is equal to rho only. Old resistivity, because resistivity is independent from the physical dimension of the wire. It depends on the type of material. Getting the point? Okay. Now question number 3. A given wire of resistance 1 ohm. Is stretched to double of its length. What will be the new resistance? It is again this question number. Okay. Yes. Sorry for that disturbance. Yes. So the question 3 is same as question number 1. Now, yes, question number 3 is same as question number 1. A resistance of 1 ohm. This is the resistance of 1 ohm. This is the old resistance. Is stretched double to its length. To its length. Means what will be the new resistance? So new resistance will be 4 times of old resistance. Simple. Because just we have calculated 4. What is the relation? 4 times. If it is doubled, then the resultant will be 4. So the final answer will be 1 into 4 is equal to 4 ohm. So question number 3 is the application of question number 1. Okay. Now see this question number 4. The temperature coefficient of resistance of a wire is this one. This is the temperature coefficient. Its resistance is 1 ohm at 300 Kelvin. At what temperature its resistance will be 2 ohm. So the simple formula for this one is equal to R new is equal to R old into 1 plus alpha into del T. This is the formula for solving this type of questions. Okay. So what is this del T? So let's say this R old is at temperature T1 and this R new is at temperature T2. So what is the difference in temperature? Said that difference in temperature is what? T2 minus T1. What is this alpha? Alpha is equal to the temperature coefficient. Temperature coefficient of resistance. This is what? This is alpha. So now put the value of alpha and delta in this question. So it is given the temperature coefficient of resistance of a wire is 0.0012 per degree centigrade. Its resistance is 1 ohm at 300 Kelvin. At what temperature its resistance will be 2 ohm? Means new resistance is given. What is the value of new resistance? 2. What was the value of old resistance? 1. 1 plus. What is the value of alpha? Alpha is equal to 0.0012. And what is the value of temperature? So earlier its temperature is 1 ohm at 300 K. At what temperature its resistance will be 2 ohm? Means it is asking about T2 minus T1. And what the value of T1 is what? The value of T1 is equal to 300 Kelvin. You have to find out the value of T2. But one more thing, this T1 into T2, you can use the degree centigrade scale. But what is the temperature given here? 300 Kelvin. So one relation is also mentioned here. Degree centigrade and degree Kelvin. Degree centigrade is equal to Kelvin minus 273 degree centigrade. 273. So let me write this question here again. So it is asking the old resistance, new resistance, old temperature, new temperature, and alpha. These are the quantities. Old resistance, old temperature, new temperature, and alpha. So the old resistance is 1 ohm at 300 degree Kelvin. 300 Kelvin. So write 1 ohm and old is what? 300 Kelvin. Now what is other quantities given? Alpha is 0.0012. Alpha is 0.0012 per degree centigrade. No issue. R new is, it is given here, it is 2 ohm. It is 2 ohm. So you just put R new is equal to 2 ohm, and this is unknown. This is unknown. Getting? And one relation is there. Degree centigrade is equal to Kelvin minus 273. This is the relation also you need to remember. Degree centigrade is equal to Kelvin minus 273. Okay. So this is the formula, and these quantities are given except this. This you need to find out. Now what formula you are going to use? R new is equal to R old 1 plus alpha T new minus T old. This is the formula. Now put the value. R new is equal to what? 2. R ohm is what? 1. 1 plus alpha is what? 0.0012 per degree centigrade. Why per degree centigrade? Because its collective unit will be degree centigrade. Its unit will be 1 upon degree centigrade. Degree centigrade cancel. 1 is constant. Resultant unit will be the unit of this R, which is nothing but ohm. That's why. So this is 0.0012 inside the bracket T new. T new you have to find out minus T old. T old is what? 300 degree Kelvin. Now calculate the degree centigrade counterpart of. So degree centigrade is equal to Kelvin minus 273. So 300 minus 273. It is 27. So it is what? 27 degree centigrade. So you can write here 27. Now solve this particular equation for this T new. So you can solve it directly by, let's say it is 2 is equal to, this is 1 plus 0.0012 inside the bracket T new minus 27, then 2 minus 1 upon 0.0012 plus 27. This will be T new. So it is 2 minus 1 divided by 0.0012 equal to this one plus 27. So it is equal to 860. 860 degree centigrade is equal to T new. At this temperature, its resistance will reach from 1 to 2 ohm. Getting this point? This is the answer. What is the answer? 860 degrees centigrade. Okay. So, but you have to give the answer in Kelvin. You have to give the answer in Kelvin. So Kelvin will be 860 plus 273 plus 273. So the answer will be 1133.33. 1133.33 Kelvin. So just check the answer. It is given here 1133. This is 1133.1133 Kelvin. This is the answer. So this question exclusively came in SPSC examination. Getting? So is this question is clear or I need to repeat? Just drop a message in the chat box. Otherwise we will move to question number 5, because all these questions are very important. These are the temperature dependent resistance. Getting? Okay, so let me check your message. Okay, now come to the question number 5. This is again very interesting and important question. Question number 5. Now read the question. The charge on an electron is known to be 1.6 into 10 to the power minus 19 coulomb. Okay, in a circuit the current flowing is 1 ampere. How many electrons will be flowing through the circuit per second? Now let us write this question again. So what question number 5 is saying? Question number 5 is saying the value of charge is equal to 1.6 into 10 to the power minus 19 coulomb. 1.6 into 10 to the power minus 19 coulomb, and 1 ampere. 1 ampere current is flowing for 1 second, and we need to calculate how many electrons. This is very important. How many electrons are flowing in 1 second for ensuring the current of 1 ampere. So I is equal to 1 ampere and time is equal to 1 second, and you have to calculate number of electrons. So what is the formula? Formula for this one is equal to, what is the formula? Formula is basically current is equal to charge per unit time. I think this was the formula. I is equal to Q by T, or you can write Q is equal to I into T. And now this, am I audible now? Yes, please confirm. Am I audible? Okay. Sorry, actually, due to the heavy rain, I don't know what is happening with the network. That's why it's frequently getting disconnected from the network. So okay, please ignore it. Nah? Excuse me for this. Yes. So actually, for this question number 5, what you need to know? You need to know two formulas. Number 1, Q is equal to IT, and this Q is equal to N into E, where this Q is what? It is total charge. This E is what? Charge of an electron. This N is what? It is number of electrons. So what was given? Charge on an electron. This is the charge on an electron. So you can write it as E, and this Q is what? This is the total charge. So from this formula you can solve question number 5. So let us solve it. What was asked? So first of all, Q is equal to IT, then Q is equal to NE is equal to IT. Now you have to find out the value of N into E is equal to 1.6 into 10 to the power minus 19 is equal to I into 1, and T is equal to 1. So this N will be 1 upon 1.6 into 10 to the power minus 19 comes in the numerator and will result as plus 19. So it will be 1 upon 1 by 6. It is 1 upon 1.6. So it will be 0.625. So N is equal to 0.625 into 10 to the power 19. This is the answer, 0.625 into 10 to the power 19. Let us check whether it is given in the, yes, so it is there, 0.625 into 10 to the power 19. This is your answer. Okay, yes. If you face any difficulty like disconnection or anything, just post message in the WhatsApp group so that I can immediately check that. Okay? Yes. Now come to the question number 7. This is again very interesting question. A conductor carries a current of 0.2 ampere. Find the amount of charge that will pass. Find the amount of charge. Okay. It is asking about amount of charge. Amount of charge. Amount of charge means what? Q. Amount of charge means what? Q. That will pass through the cross sectional of conduction in 30 seconds. This is what? This is time. How many electron will flow in this time interval? Charge on an electron is equal to 1.6 into 10 to the power minus 19 coulomb. So what is given here? I is equal to 0.2 ampere. This is given. Small e is given. Time is also given. So what you have to calculate? This Q. You have to calculate this Q and this small n. Okay, so just write 0.2 ampere 30 seconds. Okay, so what is given? Question number 6. I is equal to 0.2 ampere. T is equal to 30 seconds. E is equal to 1.6 into 10 to the power minus 19. Q you have to calculate, N you have to calculate. What are the formula? Formula number 1. Q is equal to NE. Formula number 2, Q is equal to I into T. So I think first you can calculate the total charge. Q is equal to I into T. I is what? 0.2 into T is what? T is 30 seconds into 30. So it will be 30 into 2, that is 60, and 6.2. So the total charge Q will be 6 coulomb. This is the total charge. And what about E? What about this N? So this is equal to N times of E. So N will be 6 upon this E. What is the value of this E? This is 1.6 into 10 to the power minus 19. So the final answer will be 6 upon 1.6. 6 upon 1.6, 3.75. So N will be 3.75 into 10 to the power minus 19. This is the number of charges and this is the total charge. Both we have calculated by using these two formula. Formula number 1, formula number 2. You need to remember these two formula. I will after the completion of each subject, I will provide the formula notes so that you can revise your portion with the help of those formulas, and it will be understandable by those who have attended the classes. For others, it is not useful, because we have gone through the formulas. That's why we will easily pick it is related to which particular topic. So here we have used two formula for charge and number of electrons. So is it clear? Now I am moving to question number 7. So if any doubt, you can post the messages in the chat box. I can repeat the question again, because we are solving the question and we are building our concepts also with the help of questions. Okay. Now question number 7. Question number 7 we have covered. Now question number 8. Question number 8. Combined resistance and wattage of two 1 kilo ohm half watt resistors connected in series. Calculate the combined resistance. Calculate the combined resistance. It is saying you are provided two resistances having the resistance rating 1 kilo ohm and the power rating half watt. Now they are connected in series. So what will be the total resistance of the combination? Means it is saying question number 8. Question number 8. It is not 7. It is question number 8. It is saying you have been provided two resistance. Let's say this is resistor number 1 and its reading is 1 ohm and its power rating is half watt. Now this is resistor number 2. This is resistor number 1. This is resistor number 2, and it is same. They are identical, 1 ohm and half watt. Now the question is asking, they are connected in series. They are connected in series. They are connected in series. R1 and R2 are connected in series. What will be the total resistance? So what will be the R equivalent? It is what? Series connection means what? 1 plus 1 means what? 2 ohm. 1 plus 1 means what? 2 ohm. And power, if power will be 1. Get the answer is 2 ohm. Okay. Now question number 8. They are connected in series, so answer will be 2 ohm. Okay. Its answer will be 2. Since kilo is written, so you can write 2 kilo ohm. Answer is 2 kilo ohm. Okay. Now come to this one. 3 resistors, 1 watt, 2 watt, 3 watt are combined in series. What is the total resistance of the combination? Number 1. Means it is question number 9 is saying 3 resistances. 1, 2 and 3. They are connected in series. Their rating is 1 watt, 2 watt and 3 watt. What is the combination of the resistance? If the connection negligible interface, obtain the potential depth across each resistance. It is saying these resistances are connected across a 12 volt battery. 12 volt battery. Obtain the potential drop across each resistance. Okay, one misprint is here. It is not watt, it is ohm basically. It is ohm. 1 ohm, 2 ohm and 3 ohm across 12 ohm battery. So let me draw the question here. This is question number 9. It is saying 3 resistances. The value of 3 resistances are 1 ohm, 2 ohm and 3 ohm. They are connected in series. This is the series connection, and their combination is connected across a 12 volt supply. So it is asking about total resistance. R equivalent. Total resistance will be 1 plus 2 plus 3. So it is 3 to 5 plus 6 ohm. And voltage across this one, let's say this voltage is V1. Voltage across this two, let's say this voltage is V2. Voltage across this one, it is, let's say, V3. So here we can apply the voltage division rule for finding the V1. So V1 will be total voltage into resistance what? 1 ohm upon 1 plus 2 plus 3. So it is 12 upon 325 plus 1, 6. That is nothing but 2 volts. Similarly, V2 will be, what is the resistance for this V2? 2 ohm. So total voltage is 12 volt. The formula is total voltage into same resistance upon total resistance. So it will be 12 into 2 upon 6. 1, 2, 3. This is 3. This is 3. So this is 6. So 6 2 ja 12 and 2 2 ja 4 volt. And similarly V3 12 into this resistance 3 upon 6. So it will be 3 2 ja 6 and 2 6 ja 12. It is 6 volt. And if you are adding this 2, this 4, then this 6, it will become 2 plus 4 plus 6 is equal to what? 12 volt. Means this 12 volt is getting dissipated across this means KVL also satisfied. KVL also satisfied. Okay. So question number 9 is very simple. Now come to the next question. Question number 10. What it is saying? Question number 10. So it is asking about the resistance of hot tungsten filament. Tungsten filament means your what the bulb we are using in our households. This is simple filament type of bulb. So filament is made from tungsten material. So the resistance of hot tungsten filament is about 10 times to the cold tungsten filament lamp. What will be the resistance of 100 watt 220 volt lamp when it is not used? So it is very easy. It is saying ki tungsten filament lamp. Okay. Its hot resistance is equal to 10 times of cold resistance, and supply is 100 watt 220 volt. Hot resistance is equal to 10 times of cold resistance. Power rating is equal to 100 watt and voltage is equal to 220 volts. And you have to calculate what? Cold resistance. When it is not used means what? Cold resistance. Resistance you have to calculate. Okay. So it is very simple. What is the relation of power in terms of resistance? So there are three. Power is equal to voltage into current. Voltage is equal to I into R into I. So I can write I square into R. Now here also you can write P. Current is equal to V upon R. So you can write V square upon R. So you have three formulas. Power is equal to VI, I square R and V square upon R. So now it is given power is equal to what? 100 watt. So you can write P is equal to 100 is equal to V square upon R. So R will be V square. What is the voltage? 220 square divided by 100. So this R will be 220 square divided by 100. 220 square divided by 100. So it is 484. It is 484 ohm. Now tell me, this resistance what you have calculated, this will be hot. You will say the hot resistance or cold resistance. What you will say to this resistance? Drop the message in the chat box whether it is hot or cold. So definitely, if we have used the power is what? Power is the quantity which is being dissipated in the bulb when it is being used. Used means what? Hot. So this resistance which we have calculated with the help of power means what? This is hot resistance. This is hot resistance and its value is 484 ohm. And this is what? 10 times of cold resistance. It is what? 10 times of cold resistance. It was given. So R cold will be 484 divided by 10, which is nothing but 48.4 ohm. So the cold resistance will be 48.4 ohms. So let us check whether it is given in the option or not. 48.4 ohms. It is given in the option number D. Is it clear? Okay. Hot resistance. Very good. Come to the question number 11. It is same as question number 10. It is same as question number 10 and you can solve it yourself also. So let us read it. Question number 11. The resistance of a hot tungsten filament is about 10 times of cold. What will be the value of same? I think no need to solve. You can solve the question number 11 yourself. Just this is what? This is P, this is V, and this is what is given. R hot is equal to 10 times of R cold. So you can write P is equal to V square upon R hot. Simple. R hot. Getting? So you can find the value of this one, question number 11, and we can solve it here, no issue. So it is R hot will be V square upon P, and V is nothing but 200 into 200 upon 100. So it is 100. It is 2 to the 400. So R hot will be 400 is equal to 10 times of R cold. So R cold will be 400 divided by 10 is nothing but 40 ohms. So the answer will be B, 40 ohms. Okay. Now come to the question number 12. The resistance of filament of a lamp increases with increase in temperature. Okay, no issue. Means resistance is increasing with increase in temperature. Resistance and temperature are directly proportional. A lamp rated 100 watt 220 volt is connected across 220 volt power supply. If the voltage drops by 10%, then the power of the lamp will be. Okay, so it is saying ki resistance is proportional to temperature. No problem. And power is equal to what? I square R is equal to what? V square upon R. No problem. Now when the lamp rated 100 watt 220 connected to 220 volt supply, if the voltage drops by 10%, if the voltage is drops by 10%, then the power of lamp will be. So you can solve it by this method, that V is equal to P is equal to V square by R, and this is equal to 100 watt. So you can write 100 is equal to 220 square divided by R. So here your now your power is getting reduced by 10%. Your voltage is getting reduced by 10%. So the new voltage will be, so the new power P dash is equal to 0.9 times of old voltage, that is 220 volt square divided by R. So this R will be, its answer will be, what will be its answer? Yes, this R will be, if you are reducing the voltage by 0.9%, then your resistance power will reduce. So you can see, we let write the relation here. Okay, for understanding this question, just see this. P is equal to V square by R. Okay, what you are observing here, P and V are nearly proportional to each other. Means what is the relationship? P is proportional to V square. If it is reduced by 10%, means 0.9 into V square. So P will be 0.9 into 0.9 into 0.9 is equal to what? 0.81. It will be somehow 0.81 times the power will get reduced. So its answer will be this one, between 0.81 to 90. You can answer why not this one? Because it is given that the resistance, this line, the resistance of the filament is increases with temperature, means it will somehow nearly equal to 81, but it is not exactly equal to anyone, because R is not constant. It is depending on temperature. It depends on temperature. That's why we cannot use the constant value of 81. It is somehow 81 to 90 watts, because R depends on temperature. Okay, now come to the next question. Okay, I think question number 13 and question number 12, they all are same. Here also it is written, if the voltage drops by 10%, then the power of the lamp will be. So here again, what was the power? 100 watt. Here it will be 81 to 90 watt, because the condition is same. 10% drop in the voltage will cause 10% means voltage is now 0.9 times. So 9 into 9, 0.81 watt. 100 is given, so it's 81%. Okay. Now question number 14. Two lamps are rated 100 watt, 220 volts are connected, and the other is 60 watt, 220 volt are connected in parallel to electric. Means what current is drawn from the supply. Okay, no problem. So I will draw the figure for this question number 14. Okay, question number 14 is saying you have two bulbs. Let's say this is your bulb number 1 and this is bulb number 2. They are connected in parallel. Parallel means what? Their ends are connected to each other. So this is one end and this is one end, and their parallel combination is connected across a supply voltage, and the supply voltage is 220 volt, and this is the lamp 1 and this is lamp 2. Now let us write their ratings, lamp 1 and lamp 2. So the rating of lamp 1 is 100 watt 220 volt. Okay, it is 60 watt 220 volt. Matlab means one is 100, another is 60, and you have to find out the current drawn from the line. So 100, 60 and current drawn. So it is asking this bulb is of 100 watt. this bulb is of 60 watt. If they are connected across a 220 volt supply, then what will be the current drawn from the supply? This is the supply current I. This is the supply current I. How you can find this supply current? So very simple logic you can use here. This lamp 1 is directly connected across this 220 volt supply, and this lamp 2 is also directly connected across this 220 volt supply. Why I am saying directly connected? Because let's say these are the supply terminals. 220 volt, this is your supply. You are connecting one lamp here at this, like this. This is directly connected or not? Let's say this is lamp 1, and another lamp, it is also directly connected. Means directly connected means what? These are the terminals of the battery, this one and this one, and these terminals are directly connected to the lamp or not? Lamp 1 and lamp 2 means lamp 1 and lamp 2 both are getting 220 volt rated. They are getting to, because none of the resistance is placed here. None of the resistance is placed here. Only a single line is going to lamp 1 at both the ends. Lamp 1 and lamp 2 of the terminals of lamp 1 and lamp 2 are directly connected from the terminals of supply. That's why we can see they are getting the exact supply voltage. Now you can use this relation. You can use this relation. P is equal to VI is equal to I square R is equal to V square upon R. So this is the relation for P, and based on the conditions given, we can use this relation. Okay. So for lamp 1, the for lamp 1, what is the power? 100 watt is equal to what is the voltage? 220 volt. What is the current? Let's say current is I1. So this I1 will be 100 upon 220. So this I1 will be 100 upon 220. So it is 0.45. It is 0.45 ampere. Now the next current I2 will be, so for I2 means what? Lamp 2. So lamp 2, what is the power of lamp 2? 220. What current? Current is I2. So this current will be I2 will up is equal to 60 upon 220. 60 upon 220. Let us solve 60 upon 220. So it is 0.27. It is 0.27 ampere. It is ampere. So here what current is going? 0.27 ampere. Here what current is going? 0.45 ampere. So what you are observing, the lamp having the higher rating, the lamp having the higher power rating is drawing higher current. The lamp having the lower power rating is drawing lower current. And what will be the total current? This total current. So apply KCL at this point. This total current is what? I1 plus I2. It was asked, na? So this total current will be what? 0.45 plus 0.27. 0.45 plus 0.27. 0.45 plus 0.27. So the answer is 0.72. This total current is equal to 0.72 ampere. This is your answer. 0.72 ampere is your answer. The question number 14 answer is 0.72 ampere. Okay. So its answer is 0.72 ampere. Okay. Now come to the next question. Two aluminium conductors have equal cross. Two aluminium conductors have equal length. Two aluminium conductor have equal length. The cross-sectional area of one conductor is 4 times that of the another. If the conductor having a smaller cross-sectional area has resistance 100 ohm, then the resistance of other conductor will be. So let us draw the condition. Two aluminium conductors have equal length. So let us draw two aluminium conductors first. Question. Let's say this is aluminium conductor number 1 and this is the aluminium conductor number 2. And their length is same. Its length is L. Its length is also L. This is the condition number 1 which is given. What is the next condition? The cross-sectional area of one conductor is 4 times that of the other. So let us write its cross-sectional area. Let's say its cross-sectional area is A1 and its cross-sectional area is A2, and it is saying A1 is equal to 4 times of A2, 4 times of another, 4 times of A2. Okay, so smallest cross, if the conductor having a smaller cross-sectional area is 100 ohm, then the resistance of other conductor. Now what is given? Let's say its resistance is R1 and its resistance is R2. For a smaller cross-sectional area, the resistance is 100 ohms. Then you have to calculate the value of this R1. This is the question basically. So just write the fundamental relation. R is equal to rho L upon A. Put R1 is equal to L1 A1. Rho is constant because material is aluminium. So this is R1 is equal to rho into L, and L both are same. So no need to write 1 and 2. and A1 is what? A1 is equal to 4 times of A2. Okay, now write this R2. R2 is equal to rho L upon A2. So here you can put the value of R2. R2 is equal to 100 is equal to rho L is L and A2 is what? A2 is A2. So rho L upon A2, rho L upon A2, rho L upon A2 is what? 100. Now check here for R1. For R1 you can write rho L upon A2 into 1 upon 4. And in place of this rho L upon A2, you can place this 100 by 4. So the R1 will be 25 ohm. Answer is 25 ohm. So its answer will be 25 ohm. Okay. The answer will be 25 ohm. Yes. Now check this last question. Aluminium wires are preferred over copper wires for long suspension power cable because. So again, why aluminium wire is preferred over copper wire for long suspension? So just read it. Resistivity of copper is less than resistivity of aluminium. No. Density of copper is greater than density because density plays a big role for long transmission lines. If having any value having higher density, it needs higher structural support in terms of tower and all. That's why we use aluminium cables, because their density is lower as compared to copper, and their resistivity is also low as compared to copper. So the correct option is B. Okay, so these 16 questions we have covered, and please revise these questions, whatever the formulas we have used throughout. Let me summarize the formulas. So formula number one for your study purpose. So it is R new is equal to R old 1 plus alpha T new minus T old. This is one formula. Formula number 2, R is equal to rho L upon A. Formula number 3, Q is equal to Ne is equal to I into T, and E is equal to 1.6 into 10 to the power minus 19 Coulomb. Formula number 4, degree centigrade is equal to Kelvin minus 273. Okay. Formula number 5, P is equal to Vi is equal to I square R is equal to V square upon R. So these are the 4 to 5 formulas which were used for these 16 questions. Now come to the next point. So in the last class, day before yesterday, we have discussed star and delta transform. Okay. So if some connection is connected like this, okay, let's say this is 2 ohm, 2 ohm and 2 ohm. Now I am saying ki calculate its equivalent star. So let me draw from different color. Yes. Let us, now you are calculating this one. Okay. So which transformation you will use? Delta to star. Let's say this resistance is R1, this is R2, this is R3. So what will be the formula of R1? R1 will be, just remember the formula. So formulas was adjacent branches. This R1 is surrounded by this 2 and this 2. So it will be 2 into 2 upon 2 plus 2 plus 2. It is nothing but 4 by 6. It is nothing but 4 by 6 means what? 2 by 3 ohm. Similarly, R2 will again, this is R2, this is surrounded by this 2 ohm and this 2 ohm. So it will be 2 into 2 upon 2 plus 2 plus 2. It is again 4 by 6 is equal to 2 by 3 ohm, and this R3 will also 2 by 3 ohm. So what you are observing here, if the same resistance, let's say the resistance of all the values, are same, connected in delta, the resistance is same, R. So their equivalent star means this and this. It will be R by 3. Getting my point? If the same resistances are connected in delta, if they are transforming to star, the resultant will be, they will be divided by 3 times. And otherwise I can say, if some resistances are connected, let's say I am giving you a question, ki convert following star connected resistance in equivalent delta connection. So what is given? Let's say star connection is given. So this is star connection. Let's say this is 2 ohm and 2 ohm. You have to find its delta equivalent. You have to calculate this and this. Let's say it is R1, it is R2, it is R3. So what formula you will use? You can let's say you can write it as RA, RB, RC. So you have to calculate R1 in terms of RA, RB, RC. Which transformation you will use here? You will use the formula of star to delta. Okay, and we have derived the relation. What is the relation? This R1 is equal to RA plus this is R1 and is bounded by, let's say, then this. So this is R1 RA, this is RC. So it is RA RC plus RC upon RB. We have derived this equation day before yesterday. R2 will be this R2 will be RA plus RB plus RB upon RC, and R3 will be this R3 will be RB plus RC plus RC upon RA. So just put the value for any one. So let us calculate this R1. Okay, this R1, it will be RA. The value of RA, all the values are 2. So 2 plus 2 plus 2 into 2 upon 2. And the resultant will be 4, 2 to 4 plus 4 by 2. It is 2 to the 4. So it is 4 plus 2 is what? 6 ohm. All calculation will result as 6 ohm. This is 6 ohm. This is 6 ohm. What you are concluding? That if resistances are connected in star, if the same resistances, same value of resistances are connected in star and they are transforming to delta transformation, they will result as 3 times of star connected resistance, because it is what? 6. It is what? 6. It is what? 2. Means while moving from delta to star, resistances are increased, and while moving, means what are your findings? Your findings number 1, or these nodes exclusive for same values of resistances. So statement number 1, when same values of resistances are connected in star and if they are transformed to delta connection, they will result as 3 times of their old values. Getting this point? Means star to delta, what is happening? Increased by 3 times. And same delta to star, what will happen? Decrease by 3. So which type of connection is generally used for load applications? The 3-phase load should connected in star or delta? Tell me. 3R is good or R by 3 is good? I think R by 3 is good, because it will consume less power. That's why all the 3-phase loads are connected in star, because it offers 3 times less resistance as compared to delta. This is for balance load. Now let us solve a very simple problem. Now calculate equivalent resistance of following circuit, and the circuit is like this is A, this is B, this is 1 ohm, 2 ohm, 3 ohm, 4 ohm, 5 ohm. So I think this is very simple problem, because this 3 and this 4, they are connected in series or parallel? They are connected in series, because they are carrying the same current. Whatever the current is flowing through 3 ohm, the same current is flowing through 4 ohm, because none of the branch is moving from here. So first step will be 3 plus 4. Then that 3 plus 4 will, then your network will, I am drawing only this part. So it will be look like this is 2 ohm, this is 3 plus 4 ohm, this is a line, and this is another, which one? 5 ohm. This is what? 3 plus 4, 7 ohm. And this is 1 ohm. Okay, no extra. Now what will be your next step? Your next step will be this 7 and this 5. They are connected in series or parallel? So they are connected in parallel, because they are 2 terminals. I mean this is the terminal of 7. It is connected to one terminal of 5. This is the another terminal of 7. This is connected to another terminal of 5. You can see this is the same connection. Means this 7 and 5 are connected in parallel. So your final resistance will be, let's say this is RAB. So your RAB will be, again, this is 1 ohm, this is 2 ohm, and here it is 7 parallel with 5. And how to solve this 7 parallel with 5? 7 into 5 upon 7 plus 5. So that is 35 upon 12. So it is nothing but 35 upon 12. And total resistance AB means you are finding the resistance from here, so it will be RAB, and this RAB will be 1 plus 2 plus 35 by 12. This is your answer. Okay, so no need to apply star delta transformation in this question, because it is very simple. It can be solved by series parallel combination. Now let us check if you are facing this type of question, this is a commonly asked question. This pattern is commonly asked. Okay, let's say it is 1 ohm, this is terminal A, this is terminal B, and you have to find out R is 2 ohm, 3 ohm, again 2 ohm, 2 ohm, and 2 ohm. Now what will be your approach? Just check for series and parallel. So I think series and parallel concept will not be applicable in this question. This question can only be solved with the help of star delta or delta star transformation. Now observe these two, okay, these two and these two, they are connected in star because let's say this is the common point or not. Is the common point or not? So if you are going to convert this star into delta, means let's say this is 2 ohm, this is 2 ohm, and this is again 2 ohm. Then your circuit will look like, its delta equivalent will look like this one, here, here, and here. So imagine if you are getting this type of network, it will be useful for you or not. So let us draw the next part of this question, I mean next step of this question here. So what I am trying to say, either you can convert this to this to this to in from star to delta, or you can convert this to this to and this to from delta to star. Now it depends on you what I mean which step you will follow. Or you either you convert star to delta, I mean this to and this to delta, or you can convert this to and this to star. So depending on your understanding which type of transformation will result as will reduce the complexity of the circuit. Okay, so it depends on you. You have to imagine the next step. Before solving, imagine the next step in your mind. Okay, so let us, I am in the first step, I am converting this and this in delta. So what will happen? So my next circuit will be this. Okay, and I am not disturbing these resistances. These are the 3 ohm and I am not disturbing it. Okay, 3 ohm and 2 ohm. This is A, this is B, this is 1 ohm, this is 3 ohm and 2 ohm. What I am doing, I am converting these two in delta, so they will result as one terminal is here, one terminal is here, one. Okay, this is the common point, this is the common point, and these are the main points. Okay, these are the main point. So it will be from here to here, from here to here, and from here to here. This will be my new look of circuit. So what I have done, this two and this two I have converted in delta, and these two are in the same values. Same value of resistances are converted from star to delta, then they will increase by 3 times. So it will be 6 ohm, 6 ohm and 6 ohm. Now my job is very easy. Now I can see this 6 ohm and this 3 ohm, they are connected in parallel. This 6 ohm and this 2 ohm, they are also connected in parallel. So the next step will be, let's say this is 1 ohm, this is terminal number A, this is terminal number B. Now this is 6 ohm, so draw this 6 ohm first. This is 6 ohm, and obtain the parallel combination. This 6 and 3, they are connected in parallel, so they can be represented by one resistance. 6 parallel 3, and this 6 and this 2, this is also connected in parallel, so this is represented by one resistance. 6 parallel 2. Now they are connected in series, and again this combination is connected in parallel with this combination, and that combination will connected in series with this combination. Means the next step will be, first you need to calculate 6 parallel 3 means what? 6 into 3 upon 6 plus 3, 6 3 is 18 upon 9, that is what? 2 ohm. And 6 parallel 2 means what? 6 into 2 upon 6 plus 2, 6 into 2 what? 12 plus 6 plus 2 8. It will be 3 by 2 means 1.5 ohm. Okay, now your next step will be 1 6, this is 2 ohm, this is 1.5 ohm. So next step will be 1 ohm, 6 ohm, and this is A, this is B, this is RAB, and this parallel is what? This plus this, and 6 parallel 3 means 2 plus 1.5. This will be 2 plus 1.5 is nothing but 3.5. Now the next step will be, you can write directly RAB is equal to start from here. 3.5 is parallel with 6. This 3.5 and this 6 are connected in parallel, and this combination is connected in series. This combination is connected in series with this one. So this is your final answer. RAB is equal to 3.5 into 6 upon 3.5 plus 6 plus 1. So you can write it directly. 3.5 into 6 is equal to 21. 3.5 plus 6, 9.5. 9.5 plus 1. The final answer is equal to 3.21 ohm. So this is the final answer. So here you can use star to delta or delta to star. Now solve this question by another method. So I am solving this question once again for your practicing purpose only. This time I will do something different. So let me draw 1 ohm, A, B, 2 ohm, 2 ohm, 2 ohm, 2 ohm, and I think this was 3 ohm. 3 ohm. Okay. Now what I am going to do, these two, and these two, they are connected in delta, and now I am converting them in star. So my step will be, next step will be, this is 1 ohm, this is A, this is B, this is ohm, this is 3 ohm. Now what I am doing, I am converted this delta to star, so my resultant will be this. Like, and you know, if same resistances of delta connection is converted to star connection, the final resistance will decrease by 3 times. So all the resistance will be 2 by 3, 2 by. Now our job is very easy. This 2 and this 2 by 3, they are connected in series. This 3 and this 2 by 3, they are connected in series. Now this parallel, this plus this and this plus this, they are connected to parallel. I mean this branch and this branch, this is connected to parallel to each other. So you can write finally RAB. I can write directly RAB as, first I will write 2 plus 2 by 3, then I will make a bracket, then this is the parallel with 3 plus 2 by 3. Now the whole parallel combination is connected in series with 2 by 3. Now this series combination is connected with this one plus 1. This is the final answer. This is the final answer. You can solve it. So it will be, I am leaving it to you. This is mathematical calculation. Solve. You can solve it. Getting the point, and you will get the same answer. You will get the answer 3.21. So I am writing directly. Its answer will be 3. Yes. So its answer will be 3.21 ohm. Just check it tonight itself. Okay, whether it is 3.21 or not. Come to the next question. Now question based on your nodal and mesh analysis. Okay. Now if I am saying calculate the current flowing in 2 ohm resistor. Calculate the current flowing in 2 ohm resistor using nodal analysis and verify your answer using mesh analysis. Okay, so this is a very simple question. Let's say this is plus minus 10 volt, 1 ohm, 2 ohm, 3 ohm, 5 ohm. This is the very simple question, and you have to calculate the current flowing in 2 ohm resistor. Okay, current flowing in this 2 ohm resistor. So by using nodal, so what nodal is saying, assume the nodal voltage first of all at the principal node. Let's say this is the principal node. Here I am assuming a node voltage A. Now assign the branch current. Let's say I am assigning this current is I1 and this current is I2. Now write the KCL equation. So first step was assume nodal voltage at principal node. This is step number 1. Step number 2, assign branch current. Step number 3, write KCL equation at each node. Fortunately, in this question, we have only one independent node, and this node is what? This node is reference node. This node is reference node, zero potential. So these are the 3 steps. Now write KCL equation here. What you are saying, at this node, the incoming currents are I1 and I2, and the outgoing current is I. So what KCL is saying? KCL is saying sum of incoming current is equal to sum of outgoing current, means I1 plus I2 is equal to I. No problem. Now what this I1? So you can see this I1 is flowing through this 1 ohm resistor, and at this point the potential is 10 volt, and at this point the potential is VA, means for this is the rough work for this I1. Okay, this is the case. This is 1 ohm. This is node A. Here 10 volt battery is connected, and here the voltage is VA, and this is the direction of your current. Now tell me, the direction of current is following 10 volt battery or VA. So the property of the battery is to inject the current in the circuit from its plus terminal, and the same is happening here. this current is, this current is coming from this battery from its plus terminal, means this current is supporting this 10 volt, means this current is nothing but potential difference across this 1 ohm resistance. Here the potential is 10 volt and here the potential is VA. So you can write divided by resistance is 1. So finally you can write I is equal to 10 minus VA upon 1. You can ask, sir, why minus? Why not 10 plus VA upon 1? Why not VA minus 10 upon 1? Why this? Why not this and this? So simple answer is, we have, this is 1 ohm resistor, no issue. We have assumed the direction of current in this manner. Direction of current in this manner, and here the plus terminal of battery is connected, and means this assumption is supporting the polarity of this one. That's why this voltage will dominate. This 10 volt which dominate. If I have assumed the current of I like this, I VA, and here it is 10 volt, then the formula for this I will be VA minus 10 upon 1. Getting the point? This will be when I have assumed I originating from VA, but in my case I have assumed this I1 originating from this 10 volt battery. Let's say your battery was connected like this, okay, and you have assumed the I1 like this. This is 1 ohm and here it is plus VA. Then what will happen? So VA will not be positive for writing I1. This is nothing but minus plus. So earlier when it was connected in reverse manner, means plus, the current was originating from plus terminal, then this 10 volt having the positive sign. Now here the 10 volt having the negative sign, because it is violating the rule of battery. The current is coming from negative terminal. What is the standard case? Current should come from positive terminal. So battery is connected in reverse manner. That's why minus 10. Now what about this VA? What is the property of this plus? The current should release from this plus sign, but current is coming to this plus sign. Coming to this plus sign means this will be your equation 5. We will keep on practicing and writing the Keynesian equations, because this plus and minus sign is very important. But for this time only, this I1, now complete this equation. This I1 will be 10 minus VA upon 1 plus. Now just see for I2. This I2, it is coming from this VA and going towards VA, means here you can write I2 will be 5 minus VA upon this 3 ohm, this 3. So you can write, here you can write 5 minus VA upon 3 is equal to this I. This I is what? This I will be, this I is moving away from VA. This I will moving away from VA, means VA is dominating for this I and is going towards this 0 volt. So you can write VA minus 0 upon 2 for this I. For this I you can write VA minus 0 upon 2, or you can simply write VA upon 2. So here your equation will complete. It will be VA upon 2. Now let me write these equations: 10 minus VA, 5 minus VA, VA upon 2. So your final equation is 10 minus VA upon 1 plus 5 minus VA upon 3 is equal to VA upon 2. So this is the simple problem, one unknown only. So what you will do, either you can take LCM or you can equate the denominators. So what I prefer, I equate the denominators. Here it is 3 na. Here it is 2. So the common is what? 6. Now make all denominators to 6. How to make? Just multiply 6 by 6. Here you can multiply 2 by 2. Here you can multiply 3 by 3. Then our denominator will be 6, means 60 minus 6 VA upon 6. No issue. Plus 2. 5 into 2. 10 minus 2 VA upon 6 is equal to 3 VA upon 6. What is the advantage? 6, 6, 6. Cancel. Now you are having only 60 minus 6 VA plus 10 minus 2 VA is equal to 3 VA. So you can write 60 plus 10 is equal to 70. 6 and 2 having minus sign is equal to minus 8 VA is equal to 3 VA. Your next step will be 70 is equal to 3 VA plus 8 VA is equal to 11 VA. So the final answer will be VA is equal to 70 upon 11 volt. 70 upon 11 volt. But what was asked? It was asked to find the current flowing this 2 ohm resistor. This 2 ohm resistor. So what current is flowing? VA upon 2. So this I will be VA upon 2 is nothing but 70 upon 2 into 11. So this I is nothing but 70 upon 22 ampere. This is the answer. You can simplify it as I is equal to 35 upon 11 ohm. Okay, this is the correct one. Getting. Now solve the same question with the help of mesh analysis and check whether this 3511 is coming from mesh or not. So I think just drop a message in the chat box whether we should continue or we should leave it for tomorrow. Then only I will proceed because it is 9:30. If you don't have problem, I can continue from here. Just drop a message here. Someone has written, I have missed question number 6. What was question number 6? No. I think I have covered this, na? Question number 6. A conductor carries a current of 0.2 ampere. How many electrons will flow in 30 seconds if the charge on one electron is we can solve written na q I is equal to this one, n is equal to this one. We have solved it. Question number 6. Yes. So let me check your message. Okay. So I am seeing any messages. So let me continue from here. Okay. So let us solve this question from mesh analysis approach also. Yes. So the same question. Now this time we will solve the mesh equations. Okay. So this is the plus minus 10 volt, 1 ohm, 2 ohm, 3 ohm, 5 volt. This is the case. Here again you have to calculate the value of this current. Okay. Value of current flowing in. Let's say this current is I. But here you have to use mesh analysis. Means what? First of all you have to assume mesh currents. Let's say this current is IA. And let's say this current is IB. This is step number 1. So what is the step number 1? Assume mesh current. Step number 2, write write KVL equations. Okay. So KVL equations means now listen carefully. Just move with the direction of this A and the direction of this IA current is clockwise. What is the first sign you are encountering here? Minus. So write minus. What is the magnitude of battery? 10. No. Now this current is entering in this 1 ohm resistance. So entering means plus sign, relieving means minus sign. This IA current is entering in this 2 ohm resistance from upside. So plus minus. Similarly, this IB current is entering in this 2 ohm resistance from here. So plus, releasing from here, entering from here, releasing from here. In this way, we can find the value of resistance, a value of potential drop across the resistance. Now write the KVL equation for this one. So this is the minus sign, minus 10. This is the first sign is what? Plus. How much voltage? Current into resistance. Wow, what is the current? IA. What is the resistance? 1. Here, how much? What is the sign? Plus. How much voltage? 2 into current. I into R. Again, this 2 ohm resistance carrying the current of IB also, but in opposite to direction of IA. So it will be 2 into IB. 2 into IB is equal to 0. Now complete this equation. It is 2 plus 1. It is 3 IA minus 2 IB is equal to 10. And this is equation number 1. Now write the mesh equation for mesh number 2. So just move from this IB clockwise. What sign you are encountering first? Plus. So write plus. What is the resistance? 2. What is the current? 2 into IB. This is the voltage drop across 2 ohm resistance through this IB. Now write for this plus 3 into IB. Here it is plus 5. Now see this IB and see this current here. It is leaving minus sign. So it is minus 2 into IA is equal to 0. Write it properly. 3 plus 2 is 5 IB minus 2 IA is equal to minus 5. Now you have 2 equations and 2 unknowns. So solve the value of IA and IB. So you can write this equation here. It is 2 IA. This equation I am writing here. 2 IA minus 5 IB is equal to 5. I have changed this sign. Plus 2 minus, minus 2 plus. So result will remain same. Now what you can do with these 2 equations? You can same the multiplier of these 2. Getting? So you can multiply this equation by 3 and you can multiply this equation by 2. So do the same. The first will be 6 IA minus 2 into 2, 4 IB is equal to 2 into 10, 20. This is equation number 3. Same 3. Multiply this equation, this complete equation by this 3 to make the coefficient same. So 3 into 2, 6 IA minus 5 3 ja 15 IB is equal to 5 3 ja 15. This is equation number 4. Now perform this operation. Equation number 3 minus equation number 4. Equation number 3 minus equation number 4. What you will get? Just minus means what? Sign will minus. This minus will become plus. this plus become minus. So 6 and 6 cancel. 4 minus 4 plus 15 means what? Plus 11 IB is equal to 20 minus 15 is what? 5. So here you are getting this IB is equal to 5 upon 11 ampere. No problem. Now you can calculate the value of IA. Put the value of IB here in this equation. What you will get? You will get 2 IA minus 5. IB is 5 upon 11 is equal to 5. It will be 2 IA is equal to 5 plus 25 by 11. 5 plus 25 by 11. 25 by 11 is equal to this, plus 5 is equal to 7.27. So it is nothing but 7.27. Now this IA will be 7.27 divided by 2 is equal to 3.63 ampere. So your job is not over yet, because you have calculated the mesh currents IA and IB. You have not calculated this I. You are supposed to calculate this I. Now, what is the relation between this I and IA and IB? So let me draw this 2 ohm branch here. Let's say this is your 2 ohm branch and this is the current flowing the 2 ohm branch. And what current here you have assumed? This is IA. What current here you have assumed? This is IB. Now you are seeing what is the relation between I and IA and IB. So this is the relation between IA and IB. How? Because check, this IA is flowing through this 2 ohm resistance from up to down, means the IA is supporting the direction of I, and this IB current is flowing from 2 ohm from down to up. Down to up means this IA and IB are opposing to each other. IA like this and IB like this. So the resultant current will be IA minus IB. You can ask, sir, why not IB minus IA? Because what was asked, the direction of I. The direction of I is same as IA. So IA will dominate here. If we have assumed the direction of I here, so our answer should be IB minus IA. Getting the point? But here the direction of I and the direction of IA are same. That's why IA will dominate here. IA minus IB. So the value of IA is what? 3.63. Minus the value of IB is what? 5 by 11 is nothing but 0.45. 0.45. So 3.63 minus, so it is 3.17. The final current is what? 3.17 ampere. Now check it. What was the answer from nodal analysis? It was 35 by 11. Check it. 35 by 11. So it is again 3.18. It is 3.18 ampere from nodal, and from mesh it is 3.17. So they are same, nearly same. Getting the point? 3.17, 3.18. But which method you found easy? You have found easy? I think nodal analysis, because in nodal analysis we have to solve only one equation. We have to solve only one equation for VA only. And for mesh analysis, we have solved 2 equations. Means the same question can be solved. If the same question is solved by mesh analysis, be ready to solve one more equation. So it may take your extra time. So go for nodal analysis first. And if you are facing some problem with the nodal analysis, then go with mesh analysis. Getting the point? Okay. Now come to the next question. Okay, so from here onwards, we will continue from tomorrow. Okay, because it is 9:46. So thank you for your presence, and we will start our class from 7 p.m. In the evening tomorrow. Okay, thank you.